Next, we'll look at example 6.13, using molar volume in gas stoichiometric calculations. So remember that at standard temperature and pressure, the molar volume of a gas is 22.4 liters. In other words, if we have 1 mole of gas at standard temperature and pressure, it's going to take up 22.4 liters of space, okay? And we can use that information as a conversion factor. So let's work this problem. How many grams of water form when 1.24 liters of gas, of H2 gas at STB, completely react with O2? According to this equation, 2H2 plus O2 yields 2H2O. So we can convert liters in this way. Liters of H2 to moles of H2 from the molar volume here, 22.4 liters per mole. Okay? And next we can convert moles of H2 to moles of water from the balanced equation. From the balanced equation, we learned that 2 moles of H2 yields 2 moles of water. That's a 2-to-2 ratio or a 1-to-1 ratio. And then moles of water to grams of water from the molecular weight. Water is 18.02 grams per mole. So here's the calculation. 1.24 liters of hydrogen. That's 22.4 liters per mole at STP. 2 moles of hydrogen yields 2 moles of water from the balanced equation, and 1 mole of water is 18.02 grams from the molecular weight, and that gives us 0.998 grams of water formed from 1.24 liters of hydrogen. Next, we'll work the for practice problem. For practice 6.13. How many liters of oxygen at STP are required to form 10.5 grams of water? Okay, so we can work this one similarly. Grams to moles to moles to liters. Okay, so we're starting with grams of water, and we can convert to moles of water from the molecular weight. And then we'll convert to moles of O2 through the balanced equation. And then we'll convert to liters of O2 by the 22.4 liters per mole relationship. So let's get started. 10.5 grams of water, okay? And we know that water is 18.02 grams per mole. And we get that from adding it up from the periodic table. 1 mole of O2 to 2 moles of water from the balanced equation. Okay, so we have a 2-to-1 relationship. And 22.4 liters of O2 is 1 mole, and that's for any gas at standard temperature and pressure for an ideal gas. And that calculation gives us 6.53 liters of oxygen.